Okay, welcome to section A 5.6. A stands for the appendix. This section is actually in the very back of the book. This is technically an Algebra 2 topic, but I don't think you guys actually did this in Algebra 2, so that's why they just kind of stuck it at the end. So conic sections. Conic sections are the curves generated by the intersections of a plane with one or two cones in the double cone. What are we talking about? If I have two cones, one on top of one another, it's the different ways that if I have a plane that's passing through it, it's the shapes that are formed. So here's an example. Okay, here I have my double cone, right? I have two cones on top of one another, right? Here's my top cone, here's my bottom cone, and I have this plane passing through it. And you notice this one plane on the right-hand side is forming a hyperbola. See the black lines in here. Here and here. Okay, and if we do it a separate way, a different way, right, if it's more horizontal, then we have a circle, and then we can also form an ellipse when it passes through just one side, or a parabola. So those are our four different types of conic sections: parabola, ellipse, circle, and hyperbola. Since you guys already know how to do parabolas, I'm going to focus on the other three today: the ellipse, the circle, and the hyperbola. What you need to be able to get out of this today is how to graph it looking at the equation. And where's the animation? There's the animation that I wanted. Okay, so there's my two cones on top of one another. And you'll notice it was an ellipse before. Now it is a hyperbola because it's touching both of the cones. And as we keep on going, two lines, that doesn't count. We're back to a parabola, and then an ellipse, and then a circle once it's level. So those are our four different ways that plane can intersect with the two cones and form our four different types of conic sections. So I don't need to read that part. So circles. The equation for a circle, in general, if it's centered on the origin, then the equation of the circle, we're used to seeing it looking like x squared plus y squared equals r squared. Okay, and if you want to put the center in there, h comma k, then that would be x minus h squared plus y minus k squared equals r squared, right, where the center is h comma k. But the one that I want you to know is the first one, and I'm going to rewrite it another way as well. So the first one, and then you could just think about your transformations in order to change the center, okay? And since we're changing both of these in the inside, then it does the opposite of what you want. So that's why there are negative signs there. So if I have x minus 2, then I'm shifting to the right 2. If I have y minus 3, say, then I'm going to move up 3. Okay, inside, opposite, just like we've been doing all along with all of our transformations. So, like I said, I want you to know this one, as well as, I can write it in the form of x squared over r squared plus y squared over r squared equals 1. And it seems kind of ridiculous to rewrite it in this way for a circle, but you'll see why when we look at all the other ones, they're all going to look like this second form of the x squared over r squared plus y squared over r squared equals 1. Okay, they're always going to be set equal to 1. Well, at least our examples, because I made them nice for you. Okay, so I just want you to know those general forms, especially that last one. And like I said, if the center is different, then it's just your basic transformation. So I'm not going to make you memorize the ones with the h and the k. Okay, so let's do an example. I guess I can shift this one in my example. So let's say I have, where can I write? My pretty circle is in my way. Let's say I have x minus 4 squared over 25 plus y plus 3 squared over 25 equals 1. Okay, so this 4 means that I've shifted to the right 4. And then this 3 means that I shifted down 3, because that's our y value. So y changes in the up and down direction, down 3, both opposite of what we want them to do. So I just go to the right 4, 1, 2, 3, 4, and then down 3, 1, 2, 3, and there's the center of my circle. And the radius, right, 25 is my r squared, so therefore the radius is 5, so I go 5 to the right, 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5, and left, 1, 2, 3, 4, 5, and up, 1, 2, 3, 4, 5. Okay. I must have a circle tool. Let's see. That's my center. And I'm sure yours will look just as perfect as mine does. So there's my circle with a center of 4, -3, and a radius of 5. Okay, so it's just the same thing as the circle that looks like this from our general form that I told you that you need to memorize, and then we just did those transformations in order to shift it right 4 and down 3. Okay, so that's the easiest of the 3. Ellipses, not that much more difficult, okay? So it looks very similar to a circle in that we're still adding things together, only instead of x squared over r squared plus y squared over r squared equals 1, well, our radiuses our radii are different, so we'll call them a squared and b squared, okay? So this is kind of like a is the radius in the x direction, and b is the radius in the y direction. So let's say we have something like, I guess we'll do an easy one. So let's do y squared over 25 plus x squared over 36. Okay, so the radius in the y direction is 5, so I'm going to go up 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then in the x direction, I'm going to go 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's try this and see how bad it looks. Not too shabby. So it's like a little football looking thing. That's my ellipse. And like I said before, I could shift it left or right, but I'm not going to do that. I'm just doing the general case. Okay. Hyperbolas. Definitely the most difficult of these 3 things that we're going to discuss. So, since the order in which you subtract matters, okay, what are we talking about? Well, in general, you can write it in 2 different ways. X squared over a squared minus y squared over b squared equals 1. So we have a and b just like before when we had our ellipse, right? The radius is different in the x and y directions, and they're still equal to 1. But this is subtraction, okay? And I can explain that to you more tomorrow, what the differences between the addition and subtraction and what the definition of a hyperbola or an ellipse actually is. But for now, you just need to know what the equations are. So if you're subtracting, though, of course, it makes a difference if you're subtracting the y values or you're subtracting the x values. Well, it happens to be that if you have your first example here, right, if you have your x squared over a squared minus y squared over b squared equals 1, then it's opening up to the left and to the right. Okay, so we're opening up in the x direction. If x comes first, it opens up in the x direction. X first opens in the x direction. Right, in the x direction meaning left and right. Okay, if the y comes first, right, our y is positive, then it opens in the y direction. So up and down. Okay, and then it's exactly what you were doing before with an ellipse, right? So your whatever's underneath the y, okay, so in this case they put a, is the radius of your shape. You can kind of say, I haven't showed you how to actually graph it yet, but it's the radius of your shape in the y direction. So we go up a and we go down a because that one's the one that's with the y. And then looking at your b, right, that's the radius in the x direction. So we went left and right b. Okay. They switched the variables on you over here looking back at the first one, okay, but don't get confused by it. The a, right, whatever's underneath the x, x squared gives you the radius in the x direction, so we went left and right a, and then whatever's underneath your y, which in this case is b, then b goes in the x and goes in the y direction, so up and down b. Okay, so don't get confused because they switched your a and b in these examples here, which I kind of would not have done. Okay, so our equation in general, like I said, is x squared over a squared minus y squared over b squared equals 1, or it could be the opposite, so y squared over a squared minus x squared over b squared. I'll keep the same ones that they have. Okay. X comes first, it opens in the x direction. Of course, these are not functions because they do not pass the vertical line test whatsoever. And then the second one, y comes first, so therefore it opens up in the y direction. Okay, so let me do an example. Let's do an easy one that doesn't have a transformation yet. So we'll do, so I need a subtraction, we'll do x squared over 9. We haven't done 9 yet. And let me make a bigger difference between my radii so I can tell. Okay, so I put my x first, so it's going to open up in the x direction. And I'm going to go left and right 3. And then I'm going to go up and down 5 because the 5 is with the y and the 3 is with the x. So from the center, I'm going to go 1, 2, 3, 1, 2, 3. And then I'm going to go up and down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I didn't really tell you what to do next. Okay, notice in the previous slide we have these funny looking rectangles. These rectangles aren't part of the graph, right? These ones here. They're just to help you graph them. Okay, to help you sketch the rest of the graph. The only part that's the actual graph are these two things right here and here. Okay, so these are just little guides that we're going to go by. So what are the points that I just made, right? The 4 points when I went up and down A and B, I made these 4 points right here. Well, I'm going to use those in order to make my rectangle, and then I'm going to put an X through my rectangle, and then I'm going to draw it above and below, or left and right, depending on which one comes first, the x squared or the y squared. So I just go up from here and over and down and make this nice little box. Okay, and I put a line. I could use my line tool, huh? That's all right. You guys don't have it, I won't use it. Okay, so I have my 2 diagonal lines that go through each of the corners of my rectangle. Okay, and I already said that it is opening up in the x direction. Okay, so it should look like this because my x squared is positive, that one's first. And if it was opening up in the y direction, then these points would be included and it would look like this. Okay, but, where's my, I need an undo button. But it's the opposite, right? It's opening up in the x direction. So these points are part of my graph, and then it opens up this way. So 2 of those original points that I drew will always be part of your graph. So there we go. Actually, let's do one more that actually opens up in the y direction. You in here? Yes, it is. Okay, so let's do a second example that opens up in the y direction, so therefore I need my y to be positive or to come first. So I'll do, I guess I can actually shift this one for you so you have one example of that. Let's do y squared minus x. We'll just go up 1 over 16. There we go. That one sounds good. So what is your radius in the x direction? That would be 4, so I'm going to go 4. And then what is your radius here? Well, I'm dividing by 1, so I'm going to go up and down 1. Trying to include all of my choices here. So up 1, down 1, and then I would go left 1, 2, 3, 4, and then right 1, 2, 3, 4. So normally my rectangle would be right here, but because of this part up here, right, my x plus 1 means that I shifted it to the left 1. So I'm just going to go to the left 1. I guess it should be dotted. Okay, so now my center of my box, if you want to think about it that way, is negative 1 comma 0. Okay. All right, so now all I need to do is make my diagonal lines while I'm on here anyways. So let's go like, ooh, that was a bad line. I think I did better without this. So here are my 2 diagonal lines that go exactly through my corners, kind of. Here and here. Okay. And like we said, this is going to open up in the y direction, so up and down. Why do I keep missing it? There we go. This is going to open up and down, so these two are my points, here and here. My lines look a little bit off. I feel like I did better before. This is interesting. Whoop. There we go. Perfect. Okay, so now it's opening up and down. Okay, and then these are actually our asymptotes right here, these lines that I drew. Okay. So the moral of the story, if we are adding our x squared term and our y squared term, then could be either a circle or an ellipse, right? If the radii are the same, then it gives us a circle, right? If my a squared equals my b squared, then it gives us a circle. If they are different, then it gives us an ellipse. And if it's subtraction, then it's a hyperbola, and then you just need to look at whichever one's positive, it opens in that direction. The other one, it does not. So your homework is to do these 3 questions, right? Let me just start going through them. Well, I can see that these 2 are both positive. So those are my options for being either a circle or an ellipse. Since my radius in the x direction is 3, my radius in the y direction is 4, those are different, so therefore this will be an ellipse. Okay. And looking at this last one, the radius is the same for both of these, so therefore this must be a circle with a radius of 5. And this one is subtraction, so it has to be a hyperbola. And my x is positive, so therefore it is opening in the x direction. So hopefully that gives you enough information that you can complete these 3 graphs for homework. And we'll talk more about this tomorrow. If you get confused by the transformations, right, draw it without these first, and then shift it to the left one, right? Same thing over here and over here. Sketch the graph without it. I mean, you can even do the whole ellipse first if you want, and then just shift it up, down, left, and right as needed when you are finished. Okay, I hope this made sense, even if it was new to you, and I will see you tomorrow where we will do more of this.